Well, thank you all for joining me today. I'm here to preview some of the main features that are coming out in the January release. And I know a question already came in about what licenses are required for this. It should be included with all licenses that are active. So as long as your license is active in active maintenance, you will get these options. They are healthcare features as opposed to TreeAge Pro business features. So that would be a small change to that or adjustment to that. Anyway, let's go ahead and get started. So we'll talk about these three things: the full strategy Markov reporting, the changes to the simulation output reports, and combining graphs. Starting with the top one. So full strategy Markov reporting. This is something that people have asked for quite a while. Essentially, when you have, and I'm going to open up a model to demonstrate this, and it's a very simple model, but many models will have a Markov here and a Markov here representing the two strategies. And that's fine. And that way, when you run, this is not a Markov node, but if you ran the Markov cohort analysis here and looked at your report, you'd be getting everything you need for that strategy. It would have the whole cohort trace. And the same for this one. But this particular model is slightly different in that you have a strategy that has multiple Markov processes within it. And people have asked for a combined presentation of the whole strategy, even if there are multiple Markov processes within it. So yes, you could certainly always have run a Markov cohort analysis here and see what's happening to that subgroup within this strategy. And you could run another Markov process here, and you'd have that other subgroup. And that would be fine if that were the whole strategy. But essentially, what we really have is these are both part of the same strategy. And people don't necessarily want to have to combine these manually in order to understand what's happening in their strategy. So and if we go back to the model for a second, you see that that 80% of your cohort is in this subgroup and 20% is in this subgroup. So essentially, if you wanted to see the whole strategy, we should see 80% of this one and 20% of this one as potentially one report. And that's what we've built. So if I go back to the main thing, and this strategy doesn't even really exist, but if we go back to the strategy itself, that's split into multiple Markov processes. I can't run the full one with all the events because we don't want to try to track whether all the events differ. But the basic report with the states by cycle, you can run at the strategy level. And what you'll see is, sure enough, the first subgroup from the model up here and the second subgroup are both included in the combined results. So it's not just a summary, it's this subgroup and this subgroup combined in. Sure enough, 80% went to the first subgroup, 20% went to the second subgroup. And it doesn't have to be subgroups. It could be split off in any way. People who have a successful surgery go into one Markov process and have a failed surgery go into a different Markov process. It doesn't matter why they split. What we're talking about is it's split for whatever reason, the strategy split. In this case, an 80-20. And what you see in the combined report is 80% going to this one, 20% going this one, and then all the results that we saw in the individual Markov process, the original one, like the $10,000, is now not $10,000 because it's only 80%. It's not the whole cohort. It's only now 80% of that cohort in this subgroup, 80% of the $10,000. But meanwhile, you've got 20% in this other Markov process that had a slightly higher cost, but it's only 20%. And so you end up with an overall strategy, an overall cohort analysis that reflects however many Markov processes your overall strategy may have split into. And it could be 10, it could be any number you want. It's unlimited, but we want a combined report. And if I look at the state prop graph, for example, right now you're seeing literally 6 different states, right? The original states were local cancer, metastases, and dead. So this is the local cancer from the first subgroup, and this is the local cancer from the second subgroup. And this is the dead rising from the first subgroup, and this is the dead rising from the second subgroup. So we've now included, and I'm just going to close this, all the data here, which does come up and give you the whole valuation of the strategy of the 442,011.07 qualities, which was 80% of this process and 20% of this process. Now, I think there's some value there, but we wanted to give you a little bit more value in terms of, okay, well, I don't really want to even see the subgroups separated. I want to see local cancer, metastases, and dead, regardless of which subgroup you're in. So we added an additional collapse states option, which by default will assume that if the states have the same name, you want them in the same group. Now, you could change that, and you could edit the states and add additional groupings, whatever you want. But the default assumption is that we would want the local cancer, metastases, dead from the two subgroups combined. And I'm just going to use the defaults. And now it generates even a third cohort analysis, which now is the combined local cancer from both states, the combined metastases from both, I don't mean both states, the local cancer state combined from both subgroups, the metastases state combined for both subgroups, the dead, the same. And now you have the whole cohort starting the local cancer state. Why? Because both subgroups, everyone started in the local cancer state. And essentially you end up with a presentation of your data coming down to the total cost and qualities of the strategy as a whole that shows you the cohort trace, but it was a combination of the two separate, or three or four, however many you need, cohorts merging together to give you an overall presentation of what happens to your patients as they pass through this strategy. And if I go to and run the state prop again, now I'm just seeing the local cancer state go down, where this one is actually a combination of the people who were in local cancer state for each of the two subgroups combined, giving you an overall presentation of how cost was accumulated, how qualities were accumulated over time, regardless of how many Markov models you need in order to accurately represent the disease and progression. So that's that. I don't have anything. I mean, and the summary report again would be a summary of all those two subgroups put together. I'm going to just stop for a second and see if anyone has any comments, any thoughts about this. You know, whether it would be useful, whether there's something that you'd like to see changed here. I'll just see if there's any feedback on that. If there isn't, I'll just move on to the next thing. But I just want to give people an opportunity to ask questions before I move on to the next topic. Okay, well, I'm hoping that, can we have combined groups in the graphs too? Yes, so here, this was the combined one. This was the combined cohort report, but without the merging of the states. If I run the state prop on that, then the 6 states will be separate, like local cancer for each subgroup, metastases for each, et cetera. But if I go through the process of combining them through the, well, I've already combined this, right? This is both subgroups. Then from that one, sorry, I skipped around here, where I've already combined the states, then the graphs and all the output is then reflecting the 3 states that have been remerged. So there's kind of 2 steps to this process. There's running the cohort for the whole strategy where they're separate, even though they're in the same report, and then the process of being able to merge them together and get not just the main report, but all the secondary reports for the combined data. Okay, great. I don't see any additional questions for that. We can come back to any of these topics at the end, no problem, but I will move on to the next topic. So let me close all of these. And the next topic is simulation output reports. Now, many of you have run Monte Carlo simulations in our software, and you've seen what you get is a big mass of data. You get means and statistics for cost, means and statistics for effectiveness, means and statistics for net monetary benefits. Well, what we felt, and a lot of this came out of when we train, is that was not the best way to present the data. That it was a little bit hard to absorb when you're looking at it, what it really means when it's just you're just overloaded with a big mess of numeric data. So we've changed that. And when I run microsimulation, so this is a patient simulation on this model, and the structure of the model doesn't matter, but just to go through, right? It's just a cancer model with 4 strategies. And I'm going to run, let's say, 1,000 patients. And rather than have that big, huge table of data, we've tried to make it more friendly and illustrate better what's actually happened when we ran this simulation, right? What did we run? We ran a microsimulation. You know, here's a little description of what microsimulation is. How many patients do we run? 1,000. It's a cost-effectiveness model. Our willingness to pay is 50,000. And these are our 4 strategies ordered from in decreasing by net benefits. So this is the optimal strategy. So in seconds, when you look at this, you can see this is the optimal strategy, provided you have a good willingness to pay and you can use net benefits as a calculation. You immediately know which is the optimal strategy, right? No questions asked. And down here in this graph, we're trying to say, look, this is the variance you got amongst your patients, right? You had some patients who had negative net benefits, right? Because they died right away and they paid something, right? And then you had other people who had a lot of net benefits. And it's maybe better illustration by doing the effectiveness. So this would be QALYs, right? So you have some people who died literally right away, right? In each of the 4 strategies. And then you had people dying along the way, living different periods. And then you had a whole bunch of people who pretty much lived the whole 20 years. Now, it's not going to get 20 QALYs because utility wasn't one, but essentially you have this big bump at the end showing that a lot of people, you know, not a huge portion, but, you know, 15, 16% lived the whole 20 years. That could potentially be an indication that maybe 20 years isn't a long enough time horizon. If you've got this big bump of people at the end who didn't reach the end of their life, maybe we should really run this for 30 years. Those are the kinds of things we're trying to give you an illustration of what's happening through this probability distribution trend line graph of what happened to the patients that were sent to each strategy. And here are the means, right? Treatment 4 had the highest QALY, right? Had the most people who lived to the end. But this little bump here, that would be concerning to me if you wanted to be mimicking a lifetime model. That's obviously not happening if you have this big bump here. And then what we also tried to do is emphasize the reports you're most likely to use down here. Well, I'm going to do the rankings, right? Here's your ICER calculations that came from the average cost and effectiveness of each strategy. And we can use this to, sure enough, identify that, right? The highest net benefits right here, 374. That is your optimal strategy. The ICER was below 50,000. The ICER was below 50,000. We are going to switch to treatment 4. It's the optimal strategy. Okay. There was one dominated strategy. That's fine. You can also get right to the individual outcomes of each patient. And you could get to right to the statistical or aggregate statistics for every output from the model. And so we wanted to kind of give you a feeling for what is this microsimulation telling you? It's telling you this is the best strategy. This is the variation amongst the patients. And these are the reports you're probably going to want to see. In addition, there'll be more reports over here that you could run. And anything that's down here will also be repeated here. But for example, this one's set up for patient tracking reporting to record the events that occur to the patients. So I could come in here and I could say, okay, I want to see the cohort trace for treatment 4. And there it is. Now I can see what happened to my patients over time. This is all the patients aggregated. And here's my flow of patients amongst the states. Don't be distracted by these jagged lines. It's just, I should really be running more patients, and then things would start to smooth out. But essentially, those things aren't really changed. What's changed is the overall presentation, highlighting what happened and highlighting the outputs that you probably want. I'm open to questions, but I'm also going to continue and run probabilistic sensitivity analysis on the same model. So let me close some of these outputs, but feel free to use the chat anytime. Now, I know this is a patient simulation model, but just in the interest of time, I'm going to run PSA without patients. That's not correct, but I don't want us to have to wait 5 minutes for it to finish. So I'm going to run it as just a straight probabilistic sensitivity analysis. That's why I'm getting this warning, which I'm choosing to ignore. And you'll see for this one, now I've run a different analysis, right? It's sampling. We're actually going to change this text to say PSA for probabilistic sensitivity analysis. It still has a description of what it is, but the goal of PSA is not about identifying the optimal strategy. It's about identifying the impact of parameter uncertainty on your model, which means we shouldn't be necessarily showing you the same output because the output is not the same. Now, or the goal of this analysis is not the same. So up here, we're not talking about the optimal strategy. We're talking about the percentage of the 1,000 calculations that favored each strategy. Only 42%, I should say only 42% favored treatment 4. So 40%, 2% of the calculations confirmed which one was the optimal strategy, which was treatment 4. And you'll see down here in this graph, right, you have a lot. I will just use effectiveness because it's a little easier to follow. Much less variation, right? We went all the way from like 0 to 20, right? But now we're talking about model recalculation. So you're going to have a lot less variation between one model calculation and another model calculation than you would between one patient, which we don't know what's going to happen to them, and the next patient, and we don't know what happens to that person either until they're done. So you'll see a lot less variation in the results in a PSA than you would from a Monte Carlo, or excuse me, a microsimulation. And of course, the outputs that you're likely to want are going to be different as well, right? So we try to highlight a different set of outputs. Here's your acceptability curve, right? Showing the percentage as the Williams pay change that favored each strategy. Or the ICE scatter plot, which compares just 2 strategies with a graph of incremental cost and incremental effectiveness. Right, and you're seeing that treatment 2 was more cost-effective than treatment 1, a little bit less than half the time, because there's a few fewer green dots than red dots. So we're trying to make the overall presentation of our simulation output and the presentation of the secondary reports easier to follow, easier to understand, get you to what you want faster. And that was the goal of this. And it was long overdue, but we've done it, and it will be ready for January. So that's what I wanted to say on that topic. So I'm just going to hold for a second and see if there are any questions or comments that people might have on that. I hope you like it. Okay. Can we export the graphs of the dashboard? I don't think there's a way to export this one at this time. We will probably build one. Certainly all the other ones, like the ICE scatter plot that we just showed, those can all be exported. This I'm a little concerned about, because what this is really, it's a trend line from a histogram. So if you think about this treatment 4 histogram, the gray one, it's really, what are we looking at? We're looking at effectiveness. It's really this one, effectiveness, treatment 4. It's this histogram, and then that histogram with a trend line. So what you're seeing is the trend line on that main graph, because if we put all these bars in, then it would be impossible to read, because it'd be 4 sets of bars. So we behind the scenes create the histogram, then the trend line, and then the trend line ends up back here. So at this point, there's no way to export this specific graph, but all the other graphs like this one can be exported. I can send that to Excel. And there's the histogram in Excel. Now, I think there's less need to export to Excel, because we've improved the graphs so much in terms of the way they look, the options that you have. And this isn't new. This is from over the last year or so. Many more options in terms of how to control these, and you can always copy them, any graph that you want. And one second. Back to, I'm just going to paste it into here. You can paste those graphs right into Word or PowerPoint or wherever you want. So there are a lot of exports, just not that trend graph, at least not yet. Any other questions before we move on to the third and last topic? Okay, and so my last one for today, and this is another thing that people ask for, and that's the ability to combine graphs. Now, I'm not here to claim that you can combine every graph, but we tried to focus on the ones that were most likely to somebody would want to combine. So I'm going to go back to that other model, this one. And let's say that you wanted to, and this is a little bit of a not ideal example because you could do this based on the new reporting. So just imagine this was one strategy and the other strategy for a second. And I run a Markov on one, right? And I generate a survival curve from that. And here's my survival curve. But what I really want is I want to see both strategies. Again, it's not strategies. I'm just using this as an example. Both strategies survival curve on the same graph. So I can say, look, the survival is different for these two. So I could go back here, again, pretend this is a second strategy, run the same report on the second group, generate a survival curve from there. And you see this is new, this little combine button. This combine is here because there are two available survival curve graphs of the same graph. So I can hit combine. It says, okay, bring the other one in. And now you have the survival curves from both those Markov processes. So if this would be probably most useful if those two Markovs represented two treatments. You say, okay, I got my survival for one, I got my survival for the other, but I want to be able to demonstrate the impact of the treatment on survival over time. And this is giving you that ability to say, yes, I know they're separate reports, but I still want them together because that's the way I can make communicate my results, the results from my model best to my audience. And so that's what we've enabled and made that possible to do. Now, right now, we've only done a few of the graphs. We've done the survival curve from Markov models, survival curve from partition survival models, and the state prob graph, this one, from multiple multiple graphs. What's coming soon, what we haven't built it yet, it would be the ability to hide and show and rename the series, which would be, I think, very useful because, theoretically, if you wanted here, you got survival here, you might want to rename these series. Or if you were combining a couple of these, you might want to only show progression free. So we want the ability to hide some of these and maybe rename them, right? So we'd have local cancer, they both be local cancer potentially, but for two different Markov processes. That isn't built yet, but it should be ready for January. But that would be kind of an extension of the ability to combine the graphs. But again, this is something that people have asked for. Many people have asked for it, and we finally got to the top of the priority list, and it's built. So anyway, those were the three things that I was hoping to show you all today. And I'll just kind of hold here for any questions or any feedback. And I really would love feedback if you thought things should change, or if there's anything that you see that's missing from these pieces of functionality, or if you have any other ideas of something to add to a future release. We are always open to your suggestions. So I'll just leave it open, leave the floor open, and feel free to unmute yourself and ask, with your voice if you'd like. Well, I guess maybe there's no questions. I hope that's because you liked it and not because you didn't like it. But certainly we are.
Hi, Andrew. It's
yes.
Brian here. Sorry, just one question. So just to clarify again, this Markov probability analysis, is it just basically the Markov report in graphical form?
This graph?
Yeah.
Yes, exactly. It's basically. Let me close this. It's this. I'm just going back to the original report.
Okay.
Sometimes with all this data, you have all that data and you have this movement amongst the states, it can be hard to actually fully understand what you're seeing here.
Like you can't really tell the trend by just looking at the numbers.
Right. It's hard to see the trend. So if you run the state prob, you get a feeling for the trends, what's happening. And oftentimes you can identify a problem with your model. Like if you see local cancer like this, and all of a sudden it goes down to here, like drops off the face of the earth, that's not good, right? There's probably something wrong. Or if local cancer starts to go up, that's probably impossible, right? So that so these trends can be very useful. And this graph has been around for 20 years in our software, but it's useful. You should, every time you build a markup process, you should always be looking at this data and probably using at least a state prob graph to understand whether your markup process is actually representing the disease and the impact of treatment effect.
Wait, so you mean this feature is already there? I haven't personally used it, so I'm not too sure. Is it already there?
Oh yes, this has been here for 20 years.
Oh,
this
no, I said no. I know of this table. It's just that the state probability.
Yes, this state prob has been here
I never used
for
that.
a very very long time, and it is. I think it's very useful, especially.
But you're saying that this is an update in the 2022 version. Is it?
No, this state prob has been around forever. The ability to combine them into the subgroups together is new, and the ability to combine graphs after they're generated.
Okay, so I got a bit confused that the combination of the subgroups, the two, meaning you combine which two graphs again?
Well, there's three things here, so I want to be very clear.
Yep.
The basic cohort. Let me just close all of these. The basic cohort report has been around forever.
Yep.
The state prob graph has been around forever.
Yep.
The things that are new is the ability to run the overall report for multiple Markovs at the same time within a strategy.
Okay, right now it's just purely it's purely for just if I want to turn out Markov report, I can only click on one Markov node at a time.
That's exactly right. That's exactly right.
Okay.
So that's what's new, and then the ability to take those graphs, the state prob and the probability curve graphs after they're generated, which don't have to be in the same strategy, and combine those. That's new as well.
Okay.
Any other questions? Okay, well, I guess if there's no questions, I'll close, but I would like to make it very clear that any or all of you can contact me anytime with comments, suggestions, feedback, whatever you'd like. And if you are interested in previewing these things directly in a kind of one-on-one meeting now or in the future, we do that. We try to preview these and do what we call user design analysis with people all the time. So if anyone's interested in any of those things, like being a beta tester or something like that, please feel free to reach out to me. And if there's nothing further, I'll go ahead and close the meeting. But thank you all for joining me. It certainly was a pleasure having you here today.
Thank you.
Thank you all. Have a nice day.
Have a nice day. Bye-bye.
Bye.